Oh, geez. That's how good they were. I don't know. What do you think about that metal? Nails through concrete. Fairly excited.
Was it the
Structural Engineering
podcast?
Hello. Welcome to this week's episode of Structural Engineering Podcast, hosted by Zach and I, PE. If you do any mass timber design, or even any mid-rise wood design, I bet you'll know our guest this week.
So my name is Ricky McLain.
Ricky is a Senior Technical Director at WoodWorks, a member of the ASCE Wind Engineering Committee, Blast Protection Standards Committee, Offsite Construction Board, and has contributed articles to Structure Mag, among many other roles and accomplishments. We had a great time chatting with Ricky and learned a lot about mass timber. So if you're interested in the topic, sit back and enjoy.
Yeah, so my name is Ricky McLain. I'm a practicing structural engineer, work for an organization called WoodWorks. So we're a national nonprofit, basically here to act as a free resource to the building design community. So primarily we're working with architects and engineers. We have a team of about 30 people total. We all work remotely, so we don't have a central office anywhere, but we also all travel quite a bit to be able to get to the projects that need help or to present, do presentations at conferences and events. We also host a large volume of educational events ourselves. So we're, a lot of us are traveling to those and basically just being a free resource to those who need assistance on any type of wood frame project. So that could be mass timber like we're talking about today, or it could be, light frame wood construction, your common 4 or 5 story hotels, apartment buildings, podium style structures that you see really across the country at this point.
Yeah, I feel like WoodWorks is a pretty unique organization. Are there like parallels in other industries? Is there a steel or a concrete organization simply to help people?
Yeah, there are, and those, to the best of my knowledge, have started fairly recently. Mm-hmm. So there are other industry-funded organizations like ours that are providing, similar types of things in terms of really our 2 focuses are free project help assistance and then educational events. So I think from what I know, I think we do more in the educational event side of things, but there are certainly other industries and organizations doing this type of project assistance.
When would an engineer reach out to WoodWorks or architect?
Sure. I mean, honestly, the earlier in the project, the better. The main reason I say that is because collectively we have a fair amount of experience and knowledge to kind of foresee what could be the issues if you start going down this road. Mm-hmm. And so a lot of times if they've already gone down that road, it may be difficult. I mean, we can certainly help, but it may be difficult to dial it back, say, if they're having budget issues, but they've already committed to, such and such a structural grid or such and such a framing system, those types of things. So It can be at any point. Oftentimes they'll even get a call while the project's under construction, and they'll say, this is the detail we had on our plan set. It was approved. Now the site inspector is on site and he's saying, this isn't valid. Can you help us provide some justification, those types of things. So it can be at any point, but earlier the better.
So this word has come up in the industry a lot, or this term, I guess, and we keep kind of getting reached out to, hey, what is this? And that's being mass timber. It seems to be kind of the hot thing right now in structural engineering is this mass timber. Can you tell us what mass timber is?
Sure, yeah. I mean, I think the way that I like to describe it is similar to heavy timber construction, but slightly different. So most people are familiar with heavy timber construction, like the old, especially here in New England, the old mill buildings, large cross sections of wood. And kind of the old adage of that was large column, large tree. Meaning if you needed a 16 by 16 column, you had to find a tree that was big enough that you could cut a 16 by 16 column out of, right? Well, mass timber, it basically takes the best of both of those worlds. It still allows you to do that 16 by 16 column, for example, but you don't need the large tree to get there, right? So it's using large cross-sectional elements of timber, but those are made up of a number of smaller individual pieces of wood. For example, blue laminated timber, we're familiar with that. It's very simple in its composition. It's basically just 2 bi-dimensional lumber glued, pressed, and planed together. Something similar is like a nail laminated panel or dowel laminated timber. You're basically taking 2 bis on edge, nailing or connecting them with wood dowels, and it's essentially forming solid timber slabs, if you want to call it that.
Mm-hmm. Right.
Cross-laminated timber is one of the the newer mass timber products, but it's doing similar things. It's taking 2 bi-dimensional lumber, adhering it together. In this case, it's flat. The 2 bis are flat, and then alternating directions. some people describe it as like plywood on steroids.
Yeah.
So you've got those veneers in a plywood sheet. They're very thin. Each one's orienting in opposite directions. It gives you some dimensional stability for that overall panel, in terms of, because wood does absorb and give off moisture, so it keeps it dimensionally stable overall, but still allows you to have exposed timber, things like fire ratings. Mass timber is an umbrella term. It really does encompass a number of wood products, but they're generally all doing that. They're large cross sections made out of a number of smaller pieces of wood.
Yeah.
Now, something I saw, I was out at the Mass Timber Conference last year, planning to be there again this year, and something that caught my eye was this mass plywood panel. Are you seeing that being used a lot right now?
Yeah, I mean, right now it's being fabricated by a manufacturer in Oregon, Ferris Lumber, and so they're producing panels, for projects, really any type of mass timber project. There's a project under construction right now in Oakland. It's a multifamily building, and that's, I believe, the first use of MPP in the Bay Area. So I would certainly expect that to grow. Other projects have used it, say, for like stair shaft walls. It's similar to CLT, particularly so in the sense of how it's actually certified as a building product. It actually is certified as CLT, using structural composite lumber lamella, essentially.
Mm-hmm.
But yeah, I think the more mass timber starts to get used across the country, the more of these new types of products that we'll likely start to see.
What do you think brought mass timber sort of back into the forefront of construction? Obviously, like you're saying, the Northeast, 100 years ago, it's what you built out of, right? If you need a bigger structure, you need a bigger tree. But what has brought this, back in front of everybody?
I think it's been a confluence of several things. I think, right now you're probably hearing a lot in the design industry about embodied carbon, about sustainability and the need to build more sustainable structures because of the sheer volume of construction that we're going to continue to need in this country, particularly for housing. So it provides an opportunity to build in a sustainable manner because of the manner in which the wood products that go into these systems, are sustainably harvested. And so that's one reason why I think we've seen a pickup in this.
Yeah.
Another reason why is, we hear a lot about, especially in large metro areas, labor shortages, in particular on the trades. And one thing that mass timber allows is a fairly significant reduction in construction time on site, because it's all prefabricated off-site. Comes to the site, panels are set pretty quickly, and so it allows compression of that on-site schedule, thereby reducing not just labor costs but also risks associated with weather, vandalism, those types of things.
So tell me, CLT right now is not a commodity product. Efficient design has to count for variable manufacture capabilities. How do we design around this?
Yeah, sure. This is interesting to me as a structural engineer, because when we think about how we start designing buildings, a lot of it is just based on the projects that we've already done, right?
Mm-hmm.
We become very familiar with a system, and we tend to want to replicate that system because we know it's tried and true. This is true on the design side. It's also true on the construction side, right? So with mass timber, it's not just a new product, but it also requires a unique way of thinking about the design. Like you mentioned, this is not a commodity product, meaning it's very different from if you wanted to specify a W14 by 26 steel beam. You know what its properties are going to be. You don't care. You don't really need to know who's going to supply that, right? But you already know what its properties are going to be. Whereas with a lot of mass timber products, including CLT, it is variable by manufacturer. So, for example, whether you're talking about what species of lumber they're using, what grade of lumber, and does it need to be a visual aesthetic grade, or can it be more of an industrial framing grade? All of those things play into ultimately how you go about designing it. The other thing that really you need to take into account is, as the structural engineers, we need to be careful that we're not limiting this to just only one manufacturer being able to bid on project, right?
Mm-hmm.
So just like maybe for your let's say you're designing I-joists, you may do that as a basis of design, of one given manufacturer, but you give the opportunity for the contractor to propose other manufacturers of those I-joists. You're basically comparing properties. So you can do the same thing with CLT. Is you can either base it on one given manufacturer's properties and just state clearly on your drawings, this is our basis of design, or some projects are going more of a kind of a wide net approach where we're saying, them not stating a given manufacturer as a basis of design, but just listing, we designed this based on a 5-ply with a bending capacity of X, those types of properties. And then from there, work with a given manufacturer once they're chosen.
Yeah. If you're starting from scratch, say, so Zach has done some CLT design, so he doesn't get to ask this. I have not. So, how do you know, all right, I can get this bay, this is going to be sort of efficient, these spans are reasonable at this depth, having that first conversation with the architect, obviously you have to learn something before you get there, but say me, I don't know anything. Where do you know that you can start?
Yeah, sure. I mean, just maybe a shameless plug on the WoodWorks website, we actually have we put together an article that starts to address the question you're asking, because it is a very important question. And it's important to not understand just like how far can a given panel span, but other things, I think we might talk a little bit later about like fire design for mass timber, because that does have a significant effect on the structural system for mass timber. The reason for that is because mass timber is very unique in the fact that it's usually accomplishing 3 tasks with one goal, and that is it's your structure, it's often your fire resistance rating, and it's often your finish, right? So whereas if you think, say, about a structural steel building, you have your structure, then you're going to apply, say, spray fireproofing, and then you're going to have a drop ceiling, for example. So it's 3 different layers that you're doing there, whereas with mass timber, it's all one. So how do you get to, start those conversations with the architect? A lot of times, for me, you can start to have conversations like, what's the span going to be? What's the thickness going to be? But it also needs to come down to what is the construction type of the building? Because the construction type, meaning like 5A, 3B, 4, that has a direct impact on what are the fire ratings. Mm-hmm. What those fire ratings has an impact on what are your options for timber. Meaning, let's say we're doing a type 5A structure, so everything structurally usually has to have a 1-hour rating. Well, it's very difficult to get a 1-hour rating with an exposed 3-ply CLT, for example. So you might know automatically, all right, so let's look at 5-ply CLT. What that means is that we're going to be looking at spans for floors, maybe in the range of 14 to 16 feet. Whereas if we were 5B construction, no fire rating, we could look at 3-ply, but maybe now we're talking spans in the range of 10 to 12 feet. Mm-hmm. So it does kind of take an initial understanding of what are the construction type fire ratings and how does that impact spans. But generally speaking, those are some rules of thumb.
Yeah. I feel like we might as well ask some fire questions while we're kind of on that side of things. I mean, fire rating is not something that structural engineers have typically been directly involved with, right? We know to ask the question. We know steel has fireproofing. We need to make sure that structure size is accounted for. But beyond that, I think a lot of people don't know very much. They don't go farther than that, right? It's becoming more important in the structural engineer's role in mass timber. What do we need to know, do you think?
Yeah. No, it's really important. I think that just coming from my background as a practicing consulting engineer before joining WoodWorks, I agree. I never got into fire resistance ratings, right? That was the architect's job. I didn't understand it. One of the things we'll talk about with mass timber and fire is NDS. Of course, as structural engineers, we all know what NDS is, but chapter 16 of NDS, I wasn't aware it existed. And that's the chapter that deals with fire design of exposed wood members. So we're talking about mass timber. It's critically important to understand that, know what it is. And of course, I work with that regularly now. But the synopsis is basically, if you're designing, as I just mentioned, designing mass timber structure, likely a lot of it is going to be exposed, and you need to understand what are the options for construction types, and based on those options, what are you looking at for fire resistance ratings. Once you know that, then you can start to get into really the 2 main options for designing mass timber or exposed mass timber for fire resistance is to use NDS Chapter 16, which is basically a calculation-based approach that is based on fire testing that's been completed that allows you to calculate. Let's go back to our 16 by 16 column we were talking about. It allows you to calculate, say after a 1-hour or 2-hour fire, the 16 by 16 column is going to have formed some char around the perimeter of it, all 4 sides, let's say, exposed to fire. So this document, NDS, allows you to calculate how thick is that char zone, after an hour or 2 hours. And the thing with that char zone is you are losing the structural properties within that char zone, but it's also acting as an insulator so that everything inside of the char zone is at about ambient temperature. The reason that that's important is because it retains its structural integrity in that ambient wood. So let's say 16 by 16 column, 2-hour fire. We've lost about 3¼ inches on all 4 sides. So now we're down to maybe about a 9 by 9, 10 by 10 column roughly. Mm-hmm. So you take that core section and you check it structurally. Is it still adequate for the axial loads that are on it? It's not as bad as it sounds because you can get some increase factors, basically increase the allowable stresses because the code looks at a fire as an extreme event.
Are you also able to reduce the live load at all as you're going through this? Is full dead and some reduction like a seismic?
Sure, yeah. I think it depends on which way you go about this, the design. And there isn't full agreement within the industry, but basically, in my opinion, there's a couple of routes you could go. The first route is, in NDS Chapter 16, there are these increases on allowable stresses that I mentioned. Mm-hmm. So basically, for example, your bending stress increase is 2.85. So if you go that route, in my opinion, you do still use the full dead and live load because you're increasing your allowable properties using, say, an ASD design. The other option that you can do is look at reducing using the load combinations in ASCE 7. 716 introduced some new load combinations specific to what it calls extreme events, which a fire is an extreme event. So your alternative is to not use those stress increase factors in NDS, but instead use a load reduction using those load combinations in ASCE 7.
Okay. And when you're looking at, the required fire rating, is this still something that's kind of architect led? You're getting on your coordination early. You need a 2-hour fire rating because it is this type, whatever it is from the IBC, and then you kind of bring that back and apply it to your design.
Yeah, I think that for mass timber, it really does need to be a collaborative effort between architect and engineer because, like we just talked through, these are very structural based calculations, right? You're not going to expect the architect to do an axial buckling capacity check on a column, right? That's obviously going to be the structural engineer's role. The structural engineer needs to know from the architect what is the fire rating, right? So there does need to be some collaboration on this, which I think is unique in mass timber compared to other materials. Mm-hmm. And then how you go about showing that your given elements do have those fire resistance ratings is also important. Traditionally, what a lot of architects will do is basically just paste on their drawings. For our typical floor assembly, we're using UL assembly design L528 or whatever, and they'll post that assembly in their drawing set. That's basically their way of showing the building official that this floor rating meets a 1-hour fire resistance rating. Right? With mass timber, it's unique because again, if you're going this calculation-based approach, maybe the structural engineer is showing that on his drawings, her drawings, or the other option. I mentioned there are 2 options. So the calculation-based approach is one, the fire testing approach is the other. And there have been quite a few fire tests done on mass timber assemblies. Typically more floors, walls, not so much columns and beams.
This sounds like a weird conversation jump. It's because it is. We had a short connection problem, and we're coming back in a second later.
Sorry. Yeah, no, I want to kind of jump back to the topic of CLT not being a commodity, and this is something I've worked with some clients on, and so far each mass timber project I've done, we've picked a supplier early on and worked with that supplier through the design and efficiencies, and so it's come up quite a bit of how can we make this a product that we can go out to bid with, and there's been a lot of ideas thrown around, maybe specifying, like you said, a bending value or an effective EI, especially on a public bid project where it has to be taken out to bid. What approaches are you seeing the industry using for that type of structure?
Yeah, sure. No, it's a really good point because before I dive into that answer, I think just to emphasize the point that mass timber really at this point, because it's not a commodity, because it's still fairly new in the marketplace, it does require a pretty close look at optimizing the design because that influences how efficient from a cost perspective it's going to be, right? So having an understanding, we talked earlier some about things like fire and how that influences maybe what thickness of panel you're using. The other thing that goes into all of this is optimizing the efficiency of a given manufacturer's panel size, so how wide and how long it can be. Because if you're able to really maximize that for a given manufacturer, that can really start to dial in the costs. For example, let's say you wanted to use a structural grid that had a 26-foot dimension. Right? So your columns and beams are every 26 feet. And then you're probably going to have one intermediate beam. But if you're doing that, you would likely want to get as long a panel as possible. So if you did 2 of those bays, you'd be at 52 feet. Well, what if the given manufacturer you work with has panels that are 48 or 50 feet long? They're not going to be able to optimize the length of their panels. So having an understanding of that is also important in this cost conversation. And that's why design, bid, build it is usually with mass timber, it is not the most cost efficient system. So design assist, design build, and integrated project delivery, something where you can bring in the manufacturer as early as possible to get their input. It is the best route to go. Like you said, obviously you can't do that on every single project. So getting an understanding of what is say most common for a manufacturer to produce, panels in the 40 to 48 foot range. Those are fairly common. Working with that as a dimension for length, and then width of panels also has an influence on efficiency. So usually 8 to 10, sometimes up to 12 foot panel widths. So keeping those 2 basic parameters in mind, then you start doing like what you said. We know it's a 1 hour rating, so we know we're going to go 5-ply, for example. Based on that, we're going to use, basis of design is maybe something in the CLT product standard versus what one given manufacturer is producing. And then from there, use those rules of thumb that I mentioned, that 5-ply span, say 15, 16 feet. Start with that as a basis of design. Because at that point, once you do that, then you can go out to bid, and it is on the manufacturers to prove, yes, we can meet those design values, because many manufacturers have more than one option for a 5-ply, right? In some cases, it's different species of wood. In some cases, it's maybe the inner laminations are thinner. So you can just really start to base your design on something. Ultimately, once the manufacturer is selected, I think it is a good idea to go back and revisit those. You might be at a point in the structure that it's too late to say start moving columns around, but maybe you start to look at moving intermediate beams around. Those types of things to really optimize their design, their efficiency, to get the net cost overall for the project, as efficient as possible.
I think that's a good approach and makes a lot of sense. And something I've heard too is you with CLT, you kind of buy the panel, and then as it needs to be either shortened or thinned out on the width, you're kind of still paying for that waste a little bit, since it's not reusable. So an efficient design, I think, really does make the most sense with that type of product.
Do you think that it will move manufacturing of mass timber towards a commodity product or towards a sort of a standardization at some point, or it'll kind of keep in this similar product but different property world for a while?
Yeah, I've wondered the same thing myself. I think it's hard to predict at this point.
Yeah,
I think that it's inevitable that it will get closer to a commodity product, but I think it's very possible that it never truly becomes a commodity product. And to me, if you think about something similar like I-joists, right? Would you say I-joists are a commodity product? I think some say yes, some say no, right? So it does depend on the given manufacturer that you're buying those I-joists from. What strength of top and bottom flanges are they using? What is the web? Those are all things that have an influence on how far can that span? How does it perform for vibration? Same thing with mass timber, right? Because it's using commodity core products, just 2-by-dimensional wood, but you're still having to accommodate the given manufacturer's, say, press size. So I think it's going to get closer to a commodity product, but I would not be surprised if it never truly becomes one.
I feel like you would, I don't know, not lose efficiency, but the ability to have different floor plate sizes. If we were really a commodity in this case, it would almost restrict the options a little bit. So maybe it's better it stays slightly in limbo.
Yeah, and I think the other thing too that's super important with mass timber is the aesthetics. And we haven't really talked about it yet. And from a structural perspective, maybe it's not as important, but some projects are selecting a manufacturer, from what we've been told, simply based on what the color of the species of wood they use in their projects or products. So what species a given manufacturer uses one versus the other. Some are starting to use multiple species now. perhaps in response to this type of strong desire for a certain aesthetic. So I think that's also going to continue to be a reason why manufacturers have different products, is because of simply just the commodity wood that goes into their products, and that is really a basis of where they're located geographically, right? So a manufacturer in the Southeast is going to primarily use southern yellow pine. A manufacturer in the Pacific Northwest is likely going to use Douglas fir or spruce pine fir. So it's a function also of just geographically where they're located and what's the most efficient local commodity wood product to put into our mass timber systems.
Now to switch the direction here, let's go on to maybe some lateral load design with mass timber, topic Max and I deal with a lot in high seismic.
Sure.
So what's in the code, what's not in the code? What resources do designers have to use the product in such a manner?
Yeah. So I'll start out with the easier answer, which is products like, say, nail laminated timber diaphragms, NLT or DLT, shear walls, those types of things. The reason I say it's an easier answer is because you're typically covering those systems with a layer of wood structural panels, plywood or OSB. And then from there, you're basically designing it as a fully blocked diaphragm or shear wall. Right? And you're relying actually on the plywood or OSB to act as your diaphragm or shear wall. And those values are in the special design provisions for wind and seismic document from the American Wood Council. With something like a CLT product, you won't find those values currently in either in the special design provisions document or in ASCE 7. As we know, we have to find this seismic response coefficient for whatever our vertical lateral force resisting system is. So, we have an R of 6.5 for light frame wood shear walls, whereas you won't find CLT in those tables now in Chapter 12 of ASCE 7. So what are some design routes people are going? One of the main things to keep in mind with designing, let's talk about CLT for a second. Say particularly for diaphragms and for shear walls, but just talk about diaphragms for a second, is the panels themselves, the wood panels have a significant amount of strength and stiffness. So you're actually not designing to max out the capacity of the panels. You're actually designing such that the connections between the panels are what is limiting the overall capacity of the diaphragm. And specifically, you're wanting to do that to create a ductile system. Right? You don't want to have brittle failure. You have these very highly loaded panels. If you're relying on the wood itself to act as the failure mode, it's usually not going to result in a ductile system. So keeping the capacity limited by connections between panels, and specifically by the steel fasteners that are attaching, say, two panels butt together, and you have a plywood spline detail that connects those two together. You're designing it so that you're using failure mode 3 or 4 in NDS in terms of the fastener design equations, so that's your failure mode. So the steel is yielding prior to the wood failing, and you're getting a much more ductile system because of that. So those are some design approaches that people are using now. Now that stuff is not in the code or the standard, so it does certainly require conversation with the building official on a given project. But there's some really good documentation that we have on the WoodWorks website. There's a really good diaphragm design example you can also find on the web that just talks through some of these approaches. There are plans to update the next versions of ASCE 7 and the special design provisions that will hopefully include some language specific to, say, CLT diaphragms and shear walls. But for now, it's been more a project-by-project basis. And again, we provide free assistance on those types of questions.
It was interesting. I think I heard a while ago that the city of LA, I believe it was requiring CLT to be sheathed with plywood. And that just kind of blew my mind. But their argument was there wasn't necessarily designed for CLT as a diaphragm.
Right. Yeah. No, definitely. And I think that is, again, it's going back to what is predictable, or I shouldn't say predictable, what's prescriptive in the building code. What do we know based on years of use versus what's new? And that's another reason why, again, I think engineers really have a big role to play in mass timber, because if they're able to use test data, use design equations to justify, say, a given CLT diaphragm or shear wall approach, then a building official really should be taking a look at it. It's obviously up to them in the end if they're going to accept it or not. But we have seen a number of projects go that approach and successfully get project approval and implement them without that layer of plywood or OSB on top.
Yeah. What when using mass timber as the lateral system, what has that generally looked like in, say, a low and a high seismic region?
I think there's two different things. I mean, a lot of projects, I would say most mass timber projects are using the mass timber as the floor diaphragm. Mm-hmm. Diaphragms are really a function of, is it just the mass timber acting as the diaphragm? They're usually going to have a concrete topping anyways, so just to help with acoustics. So are you going to use that as the diaphragm or not? In high seismic regions, it may be. In low seismic regions, it's usually not. With shear walls, the biggest question with shear walls usually is, what is the seismic response coefficient that you're basing the design on? Historically, there have been really two documents that have at least started to have some guideline on this. The first was the US CLT handbook, came out in 2013, and it suggested an R of 2 for seismic design of CLT shear walls. And then in 2015, I believe, the state of Oregon issued a statewide alternative document basically that said you can design CLT shear walls prescriptively here in the state of Oregon using an R of 2 also. So they both use that same value. So what a lot of projects have done is, outside of, say, the state of Oregon, is they've also gone that route, say, R of 2, and really then it's up to the engineer how to detail those shear walls. Oftentimes you're looking at panel to panel connections of half lap joints where you're just simply screwing, you're using self-tapping wood screws, screwing those panels together. Some projects are using more of like a surface applied thin steel plate to attach the two panels together. And then at the base, you obviously still have your hold downs at the ends of the shear walls. In some cases, that's a custom fabricated steel hold down. In some cases, it's more of just a proprietary hold down, as you'd see, in other types of wood projects. And then also like a clip angle or some type of an angle at the base of the CLT shear wall to transfer the shear forces from the CLT shear wall down to the foundation. There have been some projects that have looked at going to a higher level of seismic detailing. Some in the form of actually looking at things like a walking CLT shear wall approach. There's been a couple of projects that implemented this, where you're actually using brackets, steel brackets towards the end of the wall that function as energy dissipation devices. So after post-seismic event, basically those steel brackets are what yield. And so you're basically just taking those out, putting new ones in, and you have a very low damage system. It's a very resilient system. Also some projects have looked at like a post-tension CLT shear wall, similar to what very common in New Zealand with post-tension concrete rocking shear walls. So there's different levels of design, I would say. It's also comes down to aspect ratio of the individual panels. Say your CLT shear wall is 20 feet long, but that's usually not one panel. So, if it's 4 5-foot panels, it may perform differently versus if it's 2 10-foot long panels. So thinking about how many of those connections between panels you have, how much energy can that dissipate in a seismic event, making it therefore more ductile. So there's kind of several aspects that go into it, but that's the approach that most projects have used.
Then I'm going to ask about using not mass timber as the shear wall for hybrid structures. So I've seen at least some photos of this sort of stuff, and it seems fairly common, especially if we're, say, using steel or concrete system as the lateral. What is the approach for this?
Yeah, sure. And that is very common, the hybrid approach of using mass timber for gravity and using something else for lateral, right? Mm-hmm. At least for the vertical lateral system, steel brace frames, steel moment frames, concrete shear walls. And that really, the main discussion there goes back to what's prescriptive in the building code, what is the building official comfortable with, in some cases, what's the design team comfortable with, right? So it does allow projects to probably get the least resistance in terms of not going beyond what's currently in the building code. CLT shear walls and diaphragms, as we mentioned, aren't currently in the building code, particular shear walls, but there are some routes to go to allow them. But if you're not looking to go that route, then something like a concrete shear wall with mass timber columns, beams, and floor slabs, is a very common system where you're getting, the approach of as much prescriptive compliance with the building code as possible. There are some nuances there to consider, in particular where the two materials interface.
Yeah.
Because of several things. I mean, number one, mass timber is fabricated to pretty tight tolerances, meaning the panel dimensions, thicknesses, sizes, those are all pretty precise. And just honestly speaking, if something like a concrete shear wall or shaft wall, may not be as precise. There might be just differences in terms of constructability and tolerance. So coming up with details where the two interface that allow field adjustment is important. Right? You can't just assume that your wall is going to be exactly where it needs to be and your beam is going to be exactly attached to it in a given manner. What happens if that wall is a 1/4 inch out or 3/4 of an inch out? So providing some details at those connections that allow that field tolerance is pretty important, because that also keeps the structure going up at the rate which it's able to do. The other thing to consider too is just how the different materials interact in terms of moisture. And we know that we talked a little bit about wood it's hygroscopic. It absorbs moisture, it gives off moisture. You might have a little bit of swelling, shrinkage, whereas, say a structural steel brace frame is not going to do that if it gets wet. So understanding how those two interact. Also temperature fluctuations, right? The structural steel frame might see some material movement due to temperature swings, whereas the mass timber wouldn't. So it really just comes down to understanding those things and detailing in particular the connections of them, the mass timber to steel, the mass timber to concrete, that allows that field tolerance, it allows that movement to occur while still getting obviously the transfer of loads that you need to do.
Yeah. Does WoodWorks have any resources to help with that connection?
Yeah, sure. I mean, probably the best thing that we have is examples of ways that other projects have gone about detailing those. So we have a really good collection of photographs and details and examples that we can help on a given project, where if somebody comes to us, has a question like, this is our situation, we've got this steel braced frame, CLT floor panels, what are some recommendations on how to connect the two? So we can certainly provide some good resources on that.
Cool. Awesome. And I guess last thing I'm curious about, are you going to be out at the Mass Timber Conference this year?
Yeah, for sure. Yeah, I think we're bringing most of our technical team, so I will definitely be there. I'm going to be doing a presentation on mass timber fire performance. And yeah, so WoodWorks is a co-host of that event with Forest Business Network. So we're really glad to partner with them on that event and really looking forward to it. If anybody is interested in learning more about mass timber, certainly check that out. And we'll have a big booth there as well. So certainly stop by the booth and we'd love to talk to you.
Sounds good. Yeah, I'll be out there. So I'm definitely going to come by and say hi in person. So
Awesome. Yeah, that's great.
Cool. Thank you very much for joining us, Ricky. That was excellent. Appreciate all the information. Definitely looking forward to reaching out to WoodWorks when I've got questions. And it's an excellent resource. So we appreciate what you do.
Please do. And I appreciate the work you guys are putting into this podcast.
All right. That was Ricky McLain with WoodWorks. And this is the end of the episode. Come on back in 2 weeks, where Zach and I will be discussing BIM in structural engineering, its uses, and maybe what its future looks like. Thanks very much.